This is Norman Elam, Cody Mayrose, and Cory, and we are here to explain the phase diagram for a partially soluble or insoluble metals in the solidus region, which is this region down here. This is liquid, this is temperature, this is the percentage, this is a phase diagram for silver and copper. We're to concentrate in the solidus region. Thing about a phase diagram is it's an equilibrium diagram. Pressure is held constant, the temperature is allowed to slowly fall, and you get to see the different compositions of the materials as a result of the falling temperature. In the solidus region, which is the region below this horizontal line, there's different phases. Go. Okay, first let's start at the eutectic point, which as you can see, as temperature decreases, the eutectic point is the lowest temperature at which all liquid exists with any composition of the phases. Below the eutectic point is the solidus region. If I was to draw a vertical line from here to here, you would see a mixture of A and B presence, A and B phases present. Anything to the left of it, you would see a composition of alpha plus eutectic. Anything to the right of it, you'd see a mixture of beta plus eutectic. And that part's pretty cut and dry, that's simple. It's a little more hairy over here. As you can see, there is an alpha region. This here is the solvus line. This is the line that dictates at a certain temperature what percentage of copper can be present in the composition at any given temperature. So if I was to start right here at, let's say, about 5% of copper in this composition, and I reduce the temperature below this line, the copper has to precipitate out and form its own lattice. Above this line, at this temperature, the two can coexist together in the same lattice. But once it goes below the solidus line, the copper must precipitate out and form its own lattice. Go. What I was talking about before, the solidus line on this side dictates how much of each composition can be present in the lattice at any given temperature. The same goes for this side. As you can see, there's different percentages at different temperatures. That has to do with the atomic makeup of the elements themselves. This is the solidus line for the beta side, or what is copper in this case. So as the temperature drops, you can see that this solidus line moves more and more towards being pure copper, and the silver must precipitate out at the given temperature. So if I was to start at this point, which is roughly 98% copper, the two can exist in the same matrix. They can exist together. They're still soluble. But once that temperature drops, and this goes beyond the solvus line into this area, then there must be beta plus a eutectic mixture present as the beta precipitates out. And that is the explanation of phase diagram for partially soluble, insoluble metals in the solidus region.